Good morning, Rio Grande third graders. It's time to play Check Your DMA. So let's take a look at our week 20, day 2 problems of the day. So we first want to take a look at our addition sentence or equation here. So our addition number sentence or equation asks us to find the sum, which is our total, right? We call that the sum of 498 and 439. What this tells us is we are going to combine these two amounts as one lump sum. So that means we're going to have two add-ins and we're going to add them together. So I'm going to do this first using the break apart strategy. So I'm going to add my 400 and my 400, and that will give me 800. Then I'm going to take my tens, and I have 90 and 30. So 90 and 30 more. Now 90 is really close to 100. It's 10 away. So if I take a 10 from this 30, which would leave me with 20, I could take this 90 and this 10 and make it into 100, and then that would leave me my 20 here to make 120. This tells me that I regrouped my 10 tens, because these are tens. I have 90 and 10 makes 100. So I've regrouped. Now I have my 8 and my 9, so 8 plus 9. Now again, 9 is really close to 10. It's 1 away. So I'm going to take 1 from here and add it there, and that's going to leave me with 7. So now I have 10 and 7 makes 17. Now I put that all back together. So my ones place has 7, my tens place has 30, 2 tens and 1 10 makes 3 tens, which is 30, and 8 hundredths plus 1 more hundred is 9 hundredths. So 937 is my sum. So I can go ahead and write that here in my sum. So now what I want to do is I'm going to use the algorithm. I'm going to line up my place values to make sure that I'm not adding 8 plus 30, because we're not doing that. We're saying 8 plus 9. We can't add 8 plus 30 and get 11. That's not gonna work. So let's line up our place values. We have 8 plus 9 is 17, which we just saw right here. We carry that 10. There it is. 90 plus 10 more. That's right here, right? Or that's right here. 90 and 10 makes 100. Plus 30 makes 130. I carry that 100. Here's that 100 that I'm carrying. I'm going to carry that 100 to my hundreds place. I have 40 and 40 makes 80. And one more 10, or one more 100, excuse me, makes 900. 937. Now, another way to look at this, and some of you may have already caught this, you could take 2 from the 438, making it 437, add it here to the 498, which would be 500, because remember, when you're putting these two amounts together, it's still going to be the same amount if you take some from here and add it here, because you're just putting it all together in one lump sum anyway. So that 500 plus 437, well, 500 plus 400 is 900, and here's that 37 right here, so 937. So let's take a look at our next problem. It's a word problem. And remember, in word problems, we use our KFA strategy. KFA, K stands for we're going to look for the known information, right? What do we know? F stands for, right? What are we trying to find? And A stands for, yes, answer. So let's take a look at our story problem. Let's read it through. Zane has 7 watering cans. Each watering can holds 5 gallons of water. How many gallons of water will Zane need to fill all 7 watering cans? So we're looking for a total amount of water. So, again, I have 7 watering cans. Those are my groups. Each watering can is going to hold 5 gallons. That's important information to know. We're trying to find the gallons of water to fill all 7 watering cans. That's what we're trying to find. The gallons of water to fill all 7 watering cans. So let's go ahead and turn to our backside, and everybody should be doing this as well. Here's Zane, and he's got 7 watering cans. So I'm just going to draw a bar for each of my watering cans. So that's 4, 5, 6, and 7. So right now he has 7 watering cans. That's what I've drawn so far. And we fill, what do we fill each watering can with? 5 gallons of water. Each one is going to be filled with, 5 gallons of water. So we're going to fill each one with water, and it's going to be 5 gallons. Now, if you notice, the same amount is in each watering can, which tells us that we are able to, what do we know about repeated addition? You can use multiplication. So we have 7 groups. The groups are the watering cans, the water cans. The objects in each, well, the object would be water, right? So we have 5 gallons each can. And we want our total amount of water. Because we can't count water, right? But we can say it's an amount of water. And we can count the gallons, right? Gallons, total gallons of water, right? Total gallons of water, that's what they want us to find. So if we have 7 groups of 5, I could count by 5s, 5, 10, 15, 20, 25, 30, 35. I have 35 gallons of water once I have filled all the watering cans. So up here, I can finish my bar diagram using my amount of water, 35 gallons of water. So now we can take and say Zane will have 35 gallons of water because 7 cans each filled with 5 gallons will add 7 groups of 5, right? 7 groups of 5 gallons, and I'm just going to abbreviate here, to equal 35 gallons. Now, again, this is just a way to explain your thinking, but notice I have drawn a model, I have given myself an equation, and I have explained my thinking behind my equation. So make sure that you're practicing this in your DMA. All right, now let's take a look at our next problem, which has 3 factors, if you didn't notice. Look here, you have 2 multiplication symbols, and each one of my numbers in my problem is a factor. So how does this work? Well, we can use what we know about groups, right? We have 5 groups of 5. So let's start with 5 groups of 5. We know what 5 groups of 5 looks like, especially if we do an array, right? So 5 groups of 5, 1, 2, 3, 4, 5. And it's, remember, 5 rows of 5. So 5 rows, here's my 5 rows, and I'm going to put into each row 5 groups. Okay, so now I have my 5 times 5 model here. And I know that this is equal to 25 so far. But if I look over here now, this tells me I'm going to do 5 times 5 4 times. So if I do 5 times 5 4 times, then I'm going to have to draw this model 4 times. So I'm going to use a different color just to show you that this is 1 time, and that equals 25. And if I do this again, and this time I'm going to compact it a little bit, make them closer so I can fit all of this onto my screen. Okay, so there's another 25. So that's 2 groups of 25. Now, if I do another group, and this time I'm going to do it in red, so 5 rows of 5 again. So if I do 5 rows of 5 again, that's going to give me another 25. And finally, if I do this a 4th time, and this time I'm going to do my 5 times 5 in purple, five rows with 5 in each row. Now this would be something like if you have a box, and inside that box you have 25 of something, and then you put these into boxes. It's like groups of groups. And another 5 groups of 5 is going to give me 25 again. So now I can use what I know about this 25 and this 25 and this 25 and this 25, and I have 4 groups of 25 right here. So this tells me I have 4 groups of 25, or just the opposite, 4 groups of 25, right? And it doesn't matter how we use the order property tells me I can use and I can switch my factors and the product will be the same, right? So it's easier for me to think of this as 4 groups of 25 because I know what 25 plus 25 is, because I'm thinking about money. If 25 cents is a quarter and another 25 cents is 50, right? So I'm going to bring my model back over here. 25 and 25 is 50. And this 25 and 25 is also going to be 50, because I'm thinking of money. A quarter and a quarter is 25 and 25. Well, if I take this 50 and this 50 together, they make 100. And if I were to count all of these little dots in my arrays, these would all count up to 100. Now, do we want to have to count all these little dots? No, because that would be inefficient. And we want to make sure that we can do something quickly without having to do a lot of counting. So this is a visual model, but when you get to the equation, we can just go ahead and say, oh, I know 4 groups of 50 or 25 is 100. Now, another way to think about this is I could take, and remember, the only reason that you can do this is because it doesn't matter how you multiply the factors. So I could do 5 times 4, which is 20, and then I could say 5 groups of 20, and I should be able to count by 20s, 20 plus 20 plus 20 plus 20 plus 20. Well, 5 groups of 20 is 20, 40, 60, 80, 100. Still going to end up with our 100. So again, 2 different ways to look at this, but again, you can use what you know about multiplication to help you model this. Because multiplication is groups of the same amount, okay? All right, let's take a look at our last story problem, or word problem. It says Quain, or Quen, I would say Quain. Quain has 24 golf clubs, so it sounds like we know the number of golf clubs that he has. He has 3 golf bags. Okay, the bags sound like groups. Each of the bags contains the same number of clubs. Same number of clubs. Sounds like we're breaking up and sharing these golf clubs into the 3 bags. Well, let's read our question. How many golf clubs are in each bag? So yes, this sounds like a division problem because I know my total number of objects. I'm breaking or sharing them equally by saying the same number of clubs in each bag, and these are my groups. So again, I'm going to take my back of my paper and I'm going to show my work. So here's Quain, and Quain is going to have 3 bags, or 3 golf bags, and he is going to share all of these clubs, which is 24 golf clubs. Our total goes on top here. It's not 24 in each bag. It did not say there are 24 clubs in each bag. That would be multiplication, okay? That's not what it says. It says we're going to put the same number of clubs in each bag, starting with these clubs that we have here. So if I start putting clubs into bags, well, that's like me saying, okay, I have 3 groups. I don't know how many clubs are in each bag, but I do know that I have a total number of golf clubs. So if I knew my multiplication tables really well, I should be able to say, oh, I already know that there are going to be 8 in each one of these bags. But if I didn't know, I could just go ahead and start putting 1 in each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and finally 24. Well, what do we notice? We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. There are 8 clubs in each bag. Or I'm going to take the 24 clubs, because that's what's in my problem. I'm going to divide them or share them equally into 3 groups, and I have 8 in each group. So the equation that I should be using is 24 because the 24 is in my problem. I have the 3 in my problem, and this is what my question is asking me for. So I can use multiplication to help me with my division, but really what I'm doing is I'm using division to help me find how many objects are in each bag. Now I can take what I know about my problem and I could say Quain, and I really don't have a lot of room here, but I'm going to fit it in. Quain has 8 clubs in each bag because I divided the 24 clubs into 3 groups, and I got 8 clubs each bag. Okay, so we're just taking what we're doing. We modeled. We show an equation to go with what we did here. We divided, and then we responded and put a response to our division equation here. All right, those are our problems for today. Now, in your discussion today, I would like for you to take the time to round this problem to the nearest 10 and then add. So, I'm going to say it one more time. You're going to round each number to the nearest 10, and then you are going to add. Now, once you add those, find or look and see if that rounded amount is close to the exact amount. They should be really close. If they're not, you may have not rounded correctly, or there may be a problem with your addition. Now, we already know what the addition exact sum is, so it should be really close to this exact sum, especially since we're rounding to the nearest 10. So take a look at that and put that in your discussion today. Rounding each number to the nearest 10 and then adding. Okay, I can't wait to see what I get today. It'll help us practice our skills of rounding and continue that thinking. Have a great day, guys, and see you in math.